Hey everybody, good evening. My name's Philip Oldfield. I'm head of school at UNSW Built Environment. It's a pleasure to welcome you here to tonight's event. I'd like to start by acknowledging we're gathered around. I'd like to pay my respects to elders, both past and present, extend that respect to any First Nations peoples who are joining us this evening. Tonight's lecture is organised by the High Performance Architecture Research Group at UNSW Built Environment, and our mission, if you will, is to improve the environmental performance of buildings to tackle climate change in the built environment. As part of that, I would like to acknowledge that the care for the environment has been taking place on the lands that we're gathered on for tens of thousands of years, led by Indigenous knowledge, and that Indigenous knowledge and care for country is an integral part to our ongoing quest to support the environment we all enjoy, rely on. I'd also like to extend my thanks to Hassel, who is hosting tonight's event. We're really appreciative of this, being able to use this wonderful space. Tonight's topic is about designing high-density cities, and we all know that here in Sydney, our state governments have come out and said that they want to increase the density of the city, and that increasing the density is the future here, rather than suburban spread. There's no researcher in the world, I think, who has done more to understand how we can create high-density, sustainable cities than tonight's speaker, Professor Edward Ng. Professor Edward Ng is an architect and Yao Ling Sun Professor of Architecture at the Chinese University of Hong Kong. He specialises in green buildings, environmental, sustainable design, and urban climatology and city planning. And as an environmental consultant, he has spearheaded a number of incredible pieces of policy, such as the Performance-Based Daylight Design Practice Note, the Air Ventilation Assessment Technical Guidelines, and the Urban Climate Maps for City Planning. He has published over 500 papers and 3 books, and twice received the International Award from the Royal Institute of British Architects, RIBA. Very excited to hear more about what Professor Ng has got to say. So you will join me in welcoming him tonight.
It's an honor to be able to speak to you. If I say something wrong, just raise your hand, or you just give me your tomato and tomato and things like that. I like fruits very much. Okay, I've been told to use too many of my fingers, so okay. So this is the brief that Phil gave me. Say whatever you do, just mention the word density, and they will all wake up. So density, okay. Okay, I searched online, and I can see why. And I noticed that you have 50 of those in Sydney already. Keep on building. By the time you reach 500, you will start to appreciate some of the things I'm going to tell you in Hong Kong. So you have a long way to catch up. Okay, so you have no problem at the moment, to be honest. Okay, now I note something like that nearby, parking there. Can you guess the density of this thing? Now, if you want to know density, the word density, this has higher density than Hong Kong, by far. And it is even higher than the most dense city in the world, Mumbai, by far. It has about, when I calculate, 250,000 people per square kilometer. So if this thing is very big, it's like a city. But it is high density, therefore, no doubt about that. But how come you call it luxury? Okay, there's a reason why. Okay, so the reason is not what it is, but more importantly, it is what it is surrounded by that make it enjoyable. So when we talk about density and high density cities, remember it is not about what it is; it's about how it is situated and how you make it. So LDSE actually published this very good visualization of the density of cities around the world, and they try to kind of distinguish between density and cloudedness. They are not the same thing. So you have to understand that density itself is not equated to cloudedness. Okay, so beyond the old metro area of Hong Kong, which is here somewhere, Hong Kong is actually developed along the railway line, and we therefore call it linear city. So along the line into the suburban area, the city is developed linear, like this. So for example, that this is New Town, and that's a New Town, and this is New Town, something like that. And there will be a few new towns along this line later. And some of this line actually now go to the other side of the island, and new towns are being created. So this is the pattern of development that Hong Kong is now following. The new towns are therefore surrounded by what we call the seas and the country parks. So it is not what it is on its own, but how it is surrounded. So when we talk about density, we have to be very careful about, is it physical, physiological, perceptual, how you see it, emotional, or even political. So there are many ways to kind of distinguish or define this word density. Now comes the book that Phil mentioned. I'm very happy that actually when I look around, the library here actually has a copy of my book, so I don't need to give them a copy anymore. So, which is very good. So when I look at it, I can see that not many people have read it. Yeah, so it's okay. So it's very good to put it under here somewhere, just to level the desk close. Okay, and I'm quite sure that most of you have already bought this book. Yes. Okay, thank you very much. Thank you. And now I can buy my ticket back to Hong Kong. Now, if for example that you did not buy that book, which I don't think you are not, if a student or your colleagues need to buy a book and cannot afford the kind of price that this publisher is demanding, there is a Chinese version, and it costs 1/10 of the price. So you can go to Taobao and buy 10 of them and give it away. And of course, you need a Chinese wife like me to interpret the graphics for you. I have no idea who is the translator, by the way, and I have no idea when he did it. I received no royalty. That's why it's so cheap. So when I saw this, I said, "Wow, great!" And how many languages has it been translated into? I've been told that Russian, Chinese, Mongolian, and things like that. So it's very good, but I have no idea what it is. Okay, so don't blame me if they make some mistake. Now, today's lecture, I will start from giving you a little bit about the context, all the way to the design and planning. So the beginning part can be very boring for architects, but very important for researchers. Okay, so people in front need to take note, and people at the back can just enjoy yourself at the end. Okay, so I don't mind. So you can have your coffee now or later. Now, I noted this last year, and I'm quite sure you are still debating about the possible answers. So, okay, so you're asking the kind of question that we have been asking. So, and we don't know the answer. So I'm quite sure you are still trying to find the answer. If you have the answer, please tell me. Now, in Hong Kong, we have over 500 tall buildings of over 150 meters. So if you put them together close enough, you will get something like this. More will be built in Hong Kong. And if you ask me, is it getting better? I don't think I have an answer like you. So that's not the answer, the question to ask, I think. Now, I think if the question is if density is somehow acceptable, okay, not this one, of course. This is really good picture. The question should be how to do it properly. Okay, so that is the question that I may be able to give you some answer. I cannot tell you whether or not it is good or not, but I can tell you how to do it properly so that it becomes a luxury cruise ship instead of a water area. So both of them have high density, but you can distinguish them if you want. Now, this is Hong Kong, where I came from. For those of you who have not been there, please visit it. On behalf of our government tourism board, I can tell you that we are all nice people. You can enjoy good food, but try not to talk about politics. Otherwise, you may not come back. Sorry. So for those, politics is now very hot. Okay. So I'm based there. So the population is about 7.5 million. I don't know the population in Sydney is about 2 to 3 million at the moment, I believe. And the total land area is 1,000 square kilometers. So you can just about gauge how big it is as compared to Sydney. The urban area, the area that is red in color, so something like that, are the urban areas. They are approximately 250 square kilometers. So the density in those areas is about 60,000 per person per square kilometer, 60,000. But in some area, in the metro area, the density can be up to 300,000. So it's like a cruise ship in terms of density. And for those of you who are scientists, I can tell you some numbers. The average building height means average. In the metro area is 65 meters. The port ratio, if you use the word port ratio, is about 5 to 10, or sometimes higher, to 15 sometimes. And the ground coverage, i.e. how much the building occupies the ground, is approximately 50 to 70%. That's including the road. Okay. And the for those of you who are scientists, the sky view factor, how much sky you can see, is approximately 0.2 to 0.5, i.e. if you look up, you see more buildings than you see the sky and things like that. And that has a tremendous effect on urban heat island. So this is the kind of scientific data and also the demographic data of Hong Kong. Now, the interesting things about this particular map is that you can see that there is a lot of green areas. Okay, so 70% of Hong Kong's land area is green, i.e. and 40% of that is country park, i.e. you cannot build anything on it. So it's a very strange city that you live in very high density environment, but next to you is country park, which is we live there. So we walk 2 minutes to the country park, and we can walk from there to there and that takes a day, and come and go there for dinner and come back and things like that. So very close to where you live, which is very high density, are country parks that you can walk on for the entire day without seeing too much other things, which is very strange. No city, I believe, in the world has that kind of phenomenon. Oops. So this is how it looks like normally. We live somewhere down there, and these are some of the countryside that we walk to in a matter of a few minutes. This is if you're rich enough, very rich, i.e. you live in the mid-level, and you look down the city like this, and the harbor like that, and the other side like this. So this is the kind of environment that you will be experiencing in a high density city of Hong Kong. Now, I will tell you a little bit about the environmental aspect of designing this kind of city. So, but if you want to know the other aspects like social, demographic, economic, political, whatever, you have to invite other speakers. So I can only tell you part of the story that I know better about this particular kind of city area. Now, let me kind of zoom back a little bit beyond the city and see how we can understand the city better by looking at a bigger kind of picture. So for the consideration of environment, you really have to zoom out and see what is surrounding the city instead of trying to solve this problem of the city. As I say, the cruise ship depends on the surrounding areas. So one of the things that I always tell people is that if you understand the word climate zones, it means that the world has different climate. Therefore, one kind of solution may not suit another. So what I'm going to tell you later about Hong Kong some of the solutions that I'm talking about doesn't apply to you. You have different kind of problem and therefore demand a different kind of solution. So don't just copy the city next to you because it never works. And always look out for the future. So not just what it is now, but what the future of this is going to be in, say, 50 years' time. I will talk more about that later. Okay, this is now Hong Kong. Hong Kong is situated at the Pearl River Delta. You probably know the name already. For those of you who work in China, you probably know that Hong Kong is there, Guangzhou is there, Shenzhen is there, and this is the Pearl River Delta kind of river delta. So this is the area that has approximately 60 million people living there altogether. And it used to be like this many years ago. And Hong Kong was urbanized a long time ago. But 20 years ago already, this is already red. But if I show you a later picture of this, you can see that most of that is already red in Shenzhen. But Hong Kong, as you can see, still quite green in a certain way. So, but the surrounding area has been urbanized. This has created a major problem for us. What we call the plume phenomenon, i.e., the pollution, because of the surrounding landmass and also the heating phenomenon. The plume will try to recycle inside, and they will never go away. So pollution is getting worse, mainly because the surrounding areas are urbanized. So it creates a heat sink. So the air never escapes or doesn't escape as well. So you can see that if you live in that part of Hong Kong, where the airport is, the house prices are generally cheaper because they suffer a bit of higher pollution. And so if you want to know about the house price of Hong Kong, I can tell you where to go for. And I always go for the other side. This is slightly better. Of course, if you live there, you are very rich. So I don't need to talk about those people anymore. Right. Okay. Now, the second thing about the understanding the city is that it has topography, it has landscape phenomena and things like that. It means that if you try to understand what we call the dynamic quality of the environment, i.e., the wind environment, it looks something like this. It's so chaotic that you cannot say, if I design here, can I use the same design and put it there? You can't, because the land is different. The sea landscape phenomenon is different. So Hong Kong has a very complicated dynamic environment. So therefore, before you even start, you really have to look at the part of the city that you try to design there or there or there, and understand what kind of environment the nature is giving you before you start to design. So it's not very simple. I'm quite sure in Sydney it's simpler because you do not have the kind of complex landscape phenomenon that we have, and also you do not have the topography that we are talking about. This hill here is 1,000 meters, and that one there is 800 meters. So in between the two, there's a huge amount of katabatic or downhill movement of air and things like that happening, and channeling and things like that. So you have to be very careful how you understand this. Now the next thing is the street environment. A lot of times, most of the cities in the West are Greek, so they are regular. But in Hong Kong and some of the older part of the city, the Greeks are not regular, and therefore you really have to understand how all those funny kind of pockets, funny kind of angles can mean when it comes to designing the city's environment. And to be honest with you, if you design in this kind of grid and that kind of grid, the density that you can build will be very different if you want the same kind of environmental quality. So the street grid actually tells you what is the carrying capacity of the piece of land. The next thing is, of course, at the city level of open spaces and streets and things like that. For example, in this particular case, this is not Hong Kong, by the way. This is Germany that they did the study. They did the measurement of this particular square, very small square, and get this kind of result. And some of the areas are more windy, some of the areas are hotter, some of the areas are cooler and things like that. Now, the next question is it a good square? If we need to design it, some of the area will be very, very uncomfortable. Some of the area will be very chilly. So what are you going to do? Now, the idea behind it is the notion of the word inclusion. That is to say, we all demand different kind of environment. Therefore, regardless of the environment, some of the people will just sit there. Doesn't matter. Some of them will enjoy there, and so on and so forth. So the whole idea of designing a complex, high density city is that there is no one idea. There is no one kind of standard, and try not to design one kind of space. You have to design diverse kind of space that include people's wishes and also their demands. So, for example, in this particular case, the square is a very good one because everybody going to this square can find his own or her own comfort place to enjoy. So this is a good square. So when we try to simulate and try to get result of this kind of understanding, we try to make sure that the square looks like that. Now, we also did one study of Tiananmen Square. You know Tiananmen Square, the biggest square on Earth in front of some very important people. There's only one color, red, of course. Red means it's very, very hot. Red also means it's very political. So it's not good a square to linger around. Okay, other things besides. Okay, now come the street environment. This is also another study by Hermann Maier. And he chose me and he said, well, same kind of street, if you design it differently, people will enjoy differently. The environment will be different. So the same street can be designed differently for different kind of environment. For example, typically for a lot of the kind of Kenyan kind of streets are like that. But however, if you start to indent it or put in some features and also some coordinates and things like that, then the measurement is that in this kind of street, in a certain time of the day here, then nobody will find comfort. It's homogeneous. Okay, in the morning it's okay there, in the evening it's okay there, but sometime in the day that people will hate it. But however, if you design that kind of street, then you will be able to find comfort any time of the day. So when you start to design this kind of street environment, try to design it in such a way that in different time of the day, the street behaves slightly differently. The right side, the left side, or the end of the beginning, so that somehow people can navigate through the street and try to find his or her own way. And that will be a better street than a homogeneous kind of environment that this kind of street may give. Okay, this is an interesting study by my student a long time ago now. So she actually did the study that if you design your building layout in a homogeneous way like this, then environmental quality will be on average poorer than if you were to design a prison like this. Then this kind of prisons actually, if you simulate it, if you study it, will have better environment than that on the whole. Okay, and there are many reasons for that, so I don't want to go into that. But what she's trying to say is, therefore, try to design the area, the district, with different building heights, different kind of open space, larger and smaller one, and kind of come together instead of something that is cheap and nasty. In the past, I think Hong Kong developer like doing this kind of thing because if doing so, they only need to pay the architect to design one block, and they will use the stamp to stamp it 20 times, and that will be the estate. But however, nowadays we know that for the same density, this is better than that. So one of the policy of the government is actually to say, if you design something like this, we'll give you more. And therefore, the developer now say, okay, if I can have a little bit more, I will try to design like that and ask the architect to do it. The architect has a lot of fun, and the developer has also money kind of gained. and the government lose nothing, and the general public actually get a better environment. So it's a win-win-win-win-win situation. So this is what we call the port ratio transfer policy that has recently be implemented in Hong Kong's planning system. Everybody wins. But later on, I think somebody will lose, but we'll see how it goes. The next one is, of course, this is not my area of study, but I'm quite sure it's very important. The surface characteristics of building, because the surface is basically the facade of the urban environment. So what they are and how they are put together matters a lot as to what kind of radiation, what kind of heat, what kind of things that you see and things like that. So the surface are important. But on the other hand, I have to say that kind of sort those problems out earlier than the facade, then the design of the facade can be easier. And this is the area of the cool material that Mac is the expert. This is a very important slide because I'll show you both. Okay. We are all different. This is a simulation of the physical environment of the city. And you can see that some areas are blue areas are cooler, and therefore they are better, and some areas are bad. So if you talk to the planner and say, okay, what can we do? They say, oh, you try to improve those areas. That will be good. Yeah, don't worry about those. But however, if you factor in how people walk and the number of people who walk in those canyons, you can suddenly understand that actually these are the most visited area. And if something going wrong a little bit, people will feel it and people will complain. And those areas nobody goes to. So it doesn't matter if it is bad. So the resources, therefore, should be put there instead of that. So this is one way to see how the environment work when people walk in it, visit it, experience it, instead of the physical environment that you put a sensor there as if the sensor tells you everything. No, this is we try to do this by putting in what we call agent and watch how it goes and try to see how people move around in the city. And with that, then we calculate the probability, and therefore we told the government that these two streets are the most important to get better. Okay, if you get better, most of the people there will be happy, and forget about those. So, I mean, they are not in the equation. Actually, they now start to test one of them, but because of this recommendation. So what I have just told you is how we can therefore understand our city, all the way from the global climate zone to the mesoscale circulation to the city's urban heat island, and to the buildings, the behavior and performance, and topogenic forcing, what we call, and last but not least, human behavior. So my suggestion to you is always try to find ways to look this way, because there are problems there that if you don't solve it there or understand, appreciate there, then you miss the chance here. So some of these things are alien to architect, but it doesn't matter because Matt is always here to help you. And I'm quite sure Len, where's Len? Len knows enough. Yeah, she's there. Okay, and Daryl as well. So try to go to the professors and treat them nice dinner, and they will tell you everything. Okay,
That's right.
you won't charge them, do you? Oh, yeah, she will charge. Okay, so you just have to pay a little bit of money. Okay, never mind. So without doing that, then the solution that you try to solve, find is going to be very limited. Okay, now I have enough to say about the bigger picture. I go into some of the challenges. I go very quick because I think you are all bored as well. Climate change is a big problem, as you probably all know. Okay, as to how big the problem is, a Matt can tell you better. Or it's big, this big. Okay, this big. Right, and it's getting bigger. Okay, so that one I don't need to say too much. And the IPCC report has already told you us that the urban environment can have a major impact to mitigate and need to adapt to that change. So architects need to do a lot of things. Now, the second thing that is happening is urbanization. This is when I was a boy. And this is when I was a student, a PhD student at that time. And this is going to be the future that in a few years' time it will be like this. What it says is that a lot of the cities is going to get bigger, number one. And most of these cities are in the tropical belt. And these are the cities that will face a lot more climate change problem than many other cities in the world. And most of these cities are quite poor. So only that they have the problem is going to be to increase. A city is here somewhere, and you're getting bigger, but you're nowhere near the kind of problem that these cities are facing, and most of them are in Southeast Asia. The third thing, and the third thing that will happen is that, of course, middle class is going to grow bigger, as you probably know. I mean, the world is getting richer anywhere you go, and the problem with that is that the amount of resources and energy that middle class use is many times more than when they were poor. So this will have an impact on the resources demand, space demand, and the amenity demand of people. So if you were to design a city 20 years ago, people would be happy, but now they won't because they're becoming more affluent. They want more. So this is one of the problems of trying to cope with the needs of the people or the wishes of the people. So it's not physical anymore. It's getting economical. And you can see for example, the electricity use when they are getting better, the curve. It's not a straight line; it's a curve. So at a certain point, their resources need is going to jump, and the city need to, or the amenity needs will jump. So the city need to provide for that. So coping with the past demand may not be able to cope with the future demand. That's what I'm trying to say. This is important because I'm one of them now. We are getting older, so and we need some respect. Okay, so when I talk, you try not to sleep. Okay, that's kind of nonsense. Now, 1 in 3 in Hong Kong will be old people like me, and I'm quite sure that in Sydney you have a similar kind of statistics. More people will get older, and older people are more vulnerable when the environment change. Okay, so therefore treat them very nicely. Okay, yeah, things like that. And this will become a major problem. So some of the challenges that I can imagine for the environment will be this. Climate change is one of them, huge one. Urbanization will add to the problem, especially in some cities in the world. The middle class, i.e. the resources used, the kind of the wishes, and also the most important one is that we are all kind of aging. So some of these things will come back to you when you try to design. So and some of these problems were not there when you try to design cities 10 years ago, but will be there when you try to design a city 10 years from now. I don't need to tell you some of the problems that that climate change is causing. As an environmentalist, I look at this problem a little bit more than other problems. So, but as a social scientist or whatever, you may look at aging more. Now, this is another problem that the coastal city will be facing. Hong Kong, in particular, we see is storm surge every 50 years to every 2 years. So every time storm surge comes, a big problem in the city. So and more importantly, this number has gone up to 5 now. Okay, so bigger storm surge will come more often. I always tell the politicians when they look at this, they say, "So what?" They say, "Well, in the past you suffer once every 50 years or thereabout. So by the time people suffer, you're not in office already, so you're safe. But now people will suffer every 2 years. So when you're still in office, people will suffer and they will go after you. So that's hard. Then they start to listen. Okay. Otherwise, they will say, that's somebody else's problem, not my problem. So the return period has been recalculated, and therefore now for coastal development in Hong Kong, the storm surge requirement is 5 meters. So they are putting up small walls along the coastline. And imagine the coastline used to be very interesting and very good for people to walk around, but now they have a wall. So how you therefore design for it is an interesting challenge. So next time you land in Hong Kong airport, you look around, there is a small wall around the perimeter of the airport because the airport is only 4.5 meters. So they have another wall that is 1.5 meters or something like that to protect the airport because of this problem that we have identified. Water is a big problem, and Hong Kong is running out of water. I'm not too sure about you, but we are running out even in the tropics. So water will become a big. And for water management, I think the best city in the world doing that is Singapore. Singapore really manage the water and water resources extremely well because water to them is political. It's almost life and death. This one is the one that I tell you about. In the good old days, we proud ourselves of being a city that can survive any kind of storm because our drainage system is designed to cope with a storm that comes once every 200 years, which is a very good system. And the government spent billions of dollars on storm management already. But then a few months ago, September this year, a big storm came, 158 millimeters per hour came down. And then the politicians try to evade the responsibility. They say, oh, this is a once in a 500 years event. I told them, I said, there is no scientific way you can say it because 500 years ago, instrument was not ready. It was in the Song Dynasty. So how do you know? But well, even statistics doesn't tell you something like that because you have no data to correlate the distribution. So anyway, the politicians try to say, once every 500 years, it means that next one will come back in 500 years time. That's what they say. We did the calculation. And we told them that actually, we did not tell them, we told the press that, yeah, that was very important. We told the press, and said, oh, well, the politician is not that correct because this kind of storm will come back in 2 years' time. And in 50 years, within 50 years' time, another storm, much bigger storm will come, and that storm will be 300, double what you are experiencing now, or this September. And everybody wake up. Somehow. Now that we know the Hong Kong drainage system will not cope. So when you next try to go to Hong Kong, please make sure that you don't go there when we have a storm. Okay, but of course the storm only comes with 2 hours warning. So when you land, you have to talk to God, and if God say okay, then you go into the city for 2 hours and then come back. Okay, otherwise you will hit by the storm. The airport is safe. The airport is safe because of the swamp. Okay, now one of the more important things that I always this one. This is the slide that I scare them most. I say, okay, in the past you will have approximately 10 or 20 nights of hot night, 20 nights. So every year you suffer 20 nights that you cannot sleep properly without air conditioning. Okay, especially for old people, 20 nights. Okay, if we were to project to the future with a few degree rise in temperature, then the number will go from 20 to 127. The summer in Hong Kong is only 90 days long. That is to say, the entire summer month will be hot like hell. So you know the problem with heat wave. It is the duration that matters. If you have a 10 days duration of heat wave, it is much more damaging than if you were to have 8 days, something like that. So I told them that it will be more frequent. We come back almost every day in the summer. It will be more intense. Instead of 3 degrees, it will be 5 degrees. And it will last longer. Instead of 2 days, 3 days, it will last 10 days. And everybody who is going to elect you will die. This particular slide actually gave the public health service a lot of information for them to do something. It's important. So whatever you try to see what the future is like and then design for it. You can go with that, but you have to know how. When. And then we also calibrate that in the city area, the problem is more severe. The city area that the poor people live is even worse. So we told them, the government, actually, if you want to put resources into this area of concern, then this is the area that you need to do, and this is the amount of money that you may need to spend. Because we work with the public health doctors, and we know that beyond a certain threshold, I don't know what is your threshold. You have to ask your doctor what is the threshold of Sydney or Australia, and then you can see the probability of it happening. And when it happens, what are you going to do about it? Or the city need to design in such a way that that threshold is not to be exceeded beyond a certain probability. So otherwise, the people will suffer. And medical cost is very expensive, extremely expensive. This is a slide I like very much. The General Secretary of UN talked about the era of global boiling has arrived. Now you can see that these are the historical data of temperature around the year. They are all there in 100 years or so. This is last year, or in 2003, last year. It had gone beyond every single line in the last 200 years. Okay, so last year, July was the hottest. But I can tell you that scientists are now predicting that 2004 summer, this line will go higher. And I'm quite sure in 2025, this line will go still higher. So the General Secretary talks about the boiling future. That's all right. It's no joke. I.e., the reason why we need to design our city better to cope with the problem is important. This is a slide I always use to tell the people, do not try to design the future of your city using out-of-date data or yesterday's data. Okay, we are still doing that, by the way. A lot of engineers are still sizing your plant or sizing the performance of your building using the typical data of the year in the past. They're not using the future data. So I would suggest that from this point onward, you talk to an engineer, ask them to use future data to evaluate the performance of your building and the capacity of your building. If you do not have the future data, I think Matt has 2 copies. So if you ask him nicely, he will give you 1. And if it doesn't give you free of charge, ask me, I can give you. Okay, but that will be Hong Kong data. Okay, so it's quite useless for you. Right. So when we start to scare people, we go to the press and we told them that actually the problem at night, people's chances of dying will be 50% more, and then the rain will be 40% stronger or more intense. So this actually at the moment in Hong Kong has created quite a stir because the drainage department now has to recalculate all the drainage system in Hong Kong to cope with that. And more importantly, I can tell you this slope management department is now need to calculate the stability for all the slopes in Hong Kong to make sure that they can cope with this. The hospital authority is now trying to say, okay, if this kind of things happen, can we cope? Can we cope? So some of these warning systems are now being activated, at least in Hong Kong. So my Japanese friend has this slide. They say, climate change, temperature go higher. Okay. Sorry, temperature go higher is not the problem. This is the problem because once you reach the threshold, big problem will arrive. Big problem. Okay, I can tell you, to be honest, that threshold is coming very, very, very soon. It has not come yet. Already. So, okay, with all this warning system, then we also try to investigate whether or not cities around the world is ready. I can tell you that most cities are not ready. This is old data. This is data about 7 years old. So I think since then, Australia has waken up, and I'm quite sure that if we were to do this survey again, this will be another color. Red means that it's not really ready. Okay. Other color means that they are more ready. This is a document that published by the same group of IPCC on cities. What the city can do to help the situation. And this is the book that has been published. I recommend that you get hold of a copy of that and see what they have recommended. But nothing they will tell you more than what I'm going to show you today. Anyway, so don't buy them. Buy my book. Okay, so now I would like to now switch from the issue of high density to how to design the city to cope with the density problem and also some of the problems that I mentioned to you. And this is the book that I hope you can buy. Okay. It tells you a few things about how to plan a city better to cope with this kind of situation. The book basically, the methodology basically tells you what action will be required. Those are known. Again, a lot of things are known already. But importantly, where it is most needed. And this is the one that is very important for politicians to know, where they should put their resources. The thing is how much is needed. Okay, what you need to do to make sure that these kind of things are mitigated. And then most important of all, because the politician needs to be re-elected. So what benefit the public will have. So if you can quantify that, the chances of them trying to do something will be much higher. If you can't, then it's just a scary story. That's all. But I would like to focus on where it is most needed, and this is where it's spatial information. It's very architectural, therefore, and also that the impact in terms of benefits. So the methodology is called urban climatic map, which I'm going to talk about at this junction. Oops. Okay, now forget about the fuzziness of this slide. This is for researcher only to go from data all the way to implementation. There are a number of steps, and these steps have been kind of quantified in this particular book. And then you can follow the steps, and you will be able to go from the science, data, and all the way to the planning recommendation. I'll show you some examples so that you can visualize what it means. This technology we did not invent. This technology actually was by our German colleagues, and the first city that adopted technology was Berlin, and then later on it was Stuttgart. And Stuttgart people did it extremely well. So if you want to know some of the things that Stuttgart city has done in the last 40 years on trying to apply climate data to their planning system, go to their website and you'll get a lot of information. Stuttgart is a city to look at. There are other cities, Tokyo, for example, but unless you read Japanese, you cannot understand what they mean. Anyway, so the matrix that we use is how people feel in the city. And then therefore, we try to use this as a parameter to calibrate our map and therefore come up with mitigation measures. I don't want to go into this because it will be a 2 years lecture if you want to understand the human meteorology. What is it? So some of the things I am going to tell you, you won't understand. But it's good that you work with a meteorologist or somebody who understands some of these things. The good one will be able to tell you what you need to do. But not very good one will tell you what it is. So what it is does not mean anything to you. What you need to do is more important. So try to interrogate him or her to make sure that he gives you that data. Where and what and how much. Okay. With that data, you can do something. Otherwise, you don't know that it happens. You don't know what to do. Okay. Now, this is the most important slide because with this slide, you know where not to buy your next property in Hong Kong, so on and so forth. This is the urban climatic recommendation map of Hong Kong. Each color represents a certain characteristics that you should observe when you try to build on it. And more importantly, it's not the color that makes a difference. It's a pattern that make a difference. For example, even if you have a color like that, however, if the distribution is not like this, they lump together, then you don't have a problem. So you try not to. This is not a problem. For example, it has certain area that has a little bit of issues, but the way that they are gang together, you don't have any problem. Whereas in this area, you have lots of problem. So you try to detect area that has a lump and has no other way to mitigate it, then you try to solve the problem. So there's a way to read this map. It's not just the color that matters. It's the pattern of the color that makes also a difference. So this is something that I would like to warn you a little bit. So you may not be able to understand this pattern, but your meteorologist can understand it and tell you, therefore, in that area, this is the thing that you should do. Okay, so this particular system has already implemented into the Hong Kong planning framework. Now, this is the Hong Kong planning framework for the master plan or the vision plan to the statutory OZP, the outline zoning plan. I don't know what you call it in Sydney. This is the plan that is legal. So they specify the floor area, the building use, the road patterns, the density, and everything is specified here. The greenery area, the land use, everything is specified here. And they are accompanied by explanation note, i.e., that piece of land, you are allowed to build so much, but you have to build it this way. You have to observe that. You cannot do that. They're all in this map. And therefore, the architect or planner and developer will buy this map, look at it, and look at the site and say, okay, this is how much of this piece of land worth, for example, or I cannot do whatever. I have to apply for extension, things like that. So this is the planning system. The climate map that we draw together actually inform this level of understanding. So basically, this map is used by the planners to formulate this understanding. So they look at this and they will say, okay, we now do this. That's number one. Number two is that this will form the boundary conditions for your engineer, to work on a bigger scale of issue of a site planning. For example, this site is about 200 meters by 200 meters, and a few buildings will be occupied, and it has to go through the planning permission process. And then the planning permission, people will say, have you considered this? How are you going to do that? So your engineer will use this as a boundary condition to formulate recommendation that this will kind of observe some of the characteristics this map has suggested. I will show you some examples of that from this point on. So from this point on, it gets interesting because now it's project. So here's architects can understand project. This map has been incorporated into the Hong Kong Vision 2030 vision, plus vision is beyond 2030. So once it is in the vision, everybody have to observe it. So it is under the healthy city chapter of the vision plan. Okay, this is the first example of using climate data to plan an area. This is the old airport of Hong Kong, which is situated here. So when we did this map, this is all empty, but never mind, we can put in some pseudo building. Okay, and these characteristics is like that. So, and the Arab plan was to do further studies as to the dynamics. And then with that, then you simplified it by drawing a number of key kind of attributes of the city. And based on that, then the planner and some other things, of course, the planner then come up with this OZP. This OZP has a number of characteristics that has never been seen before in Hong Kong. Number one, all the major prevailing wind direction is respected. So you can see that the runway is where the wind comes from. You all know. So all these are aligned, and none of this building can be put the other way around. None of them. This is the reason why the landlord is like this and not like that. If it's like that, then the developer will do a building like that. But now they can only do a building like this. So they cannot therefore build a bad building, and that's alignment. The other one is of course the neighborhood. The old neighborhood is there. So all these things are aligned to the major streets of the neighborhood. So they are there for a reason, and they are there for a reason. This one is there for a reason, and so on and so forth. This last but not least, the ground cover of the site is reduced. In the past, they can build 100%, covering the entire ground. Now they can't. They can only do 40%. So what are you going to do with the other 60%? 30% will be greening, 20% you sort it out yourself. Now the whole idea is this. The planner asked me, if we need to build a high density city, what do we need to control? Is it building height, building bulk? I said no. These are the secondary problem that you need to deal with. The most important problem to solve, especially in a high density city, is the ground coverage of the building. If you reduce that, you solve most of the problem already. I can tell you why later. Okay, so you solve the big problem, and you allow the developer to build a smaller building, a taller building by 10%, for example, and it doesn't really affect anything environmental, but it would drastically improve the ground environment that people enjoy. So this is one thing that I always keep on telling the planet around the world. Density doesn't mean that you have to build less. Density means that you have to build intelligently. Okay, that's all. And you get the same result. But not, of course, not visually, but perceptually, but environmentally, you get the same result. Okay, so now this is the final, this is not final slide, but the solution that they try to visualize. You can see how the buildings are lined up that way. They're all like this. And the greenery is 48%, okay, more than what we recommend them to do. Because the ground level now has no podium, therefore they can plant anything they want. And it's going to be like this in the future. So next time you go and you try to visit this area, it may not be that good at the moment, because most of it are pure construction ground. But this is the first major urban development in Hong Kong that observed the urban climate standard. And now, of course, we have a problem of housing shortage. You may have the same problem, but we have a bigger problem. So the government is trying to increase density of many areas. So how are we going to do it? They ask. Okay, so I show you two examples. This is one example of an area that I've been working on. I will show you. Okay, this is Hong Kong, as you probably know by now. This is the area that we're talking about. And the climatic map has characteristics like that. And if you look at that map and look at the color, look at the distribution, we have already put in some general recommendation like this. Okay, in that area, if you have something like that, then do this, don't do that, and things like that. So these are general recommendations. However, some of the area are kind of distinct to be densified. Okay, so this general understanding is sent to some of our engineers, and then they will evaluate the situation. Okay, if there's a problem, where the solution comes from. Actually, this area is very good because it's surrounded by green hills. Hills are friends to cities because of the katabatic air movement. Cool air comes down, so it literally kind of clean your city at night. So you try to look for some of the valley system, and you try not to put the block there, otherwise you kill the system. You try to let it go through, and this is the river system that we tell them to intensify. And the few sites that we allow them to intensify are here, because a lot of help comes from that angle. So we say, okay, if we intensify some of these sites, you should have no problem. Okay, so that is a mega level, a climatic understanding of how the district could be intensified. And then when we come to this area that you try to intensify, okay, it will say, okay, if you try to benefit from some of these mega forces, bigger forces surrounding you, then you have to have non-building area of a certain quality. You need to connect some of the air path. You need to make sure that you don't build on certain area and things like that. So then this becomes the restriction of the OZP. So you cannot do whatever they don't allow you to do. So now that the site has been kind of a plan, the government sell the land to developer. We need to therefore observe this particular, for example, this particular restriction. So he cannot build a building like this. If he needs to build a building like this, he needs to put two buildings, one here and one there, and not blocking the major kind of benefit to the area and things like that. So these are now part of the planning system. The developers sometimes hate it because they can earn more money putting a big building, but we cannot earn all the money. We have to respect what nature is used. This is another area that we look at. I will tell you about this problematic area later, but this is the area that we have kind of mapped out. And then we say, okay, to solve the problem of densification that you are going to put in some of these building sites, then you have to intensify some of the air path that is going through the from the mountain at the back to the sea in front. You have to do something like that. So some of these streets you really have to widen, or you have to pedestrianize, or make it into rebound. Some of these open spaces, the blue are open spaces. You have to find which to connect them, so that the benefit is actually moved through the site from the hill to the sea. Because at night the hills give you a lot of downhill air movement, and you want to use this cool air movement to wash the city. So the only way you can do this is to link up some of the existing open spaces, and then you intensify the use of air path. Some of this area is okay, but some of these need to be intensified. Some of these squares are more important than others. So we tell them, actually, if you need to get rid of that square and try not to do it here, for example, things like that. So this has been implemented as a way to allow developers to intensify the density of this particular area. Now we come to this. How much time we have? Okay. Thank you very much. Okay. So, yeah. Any question? Or you have 10 minutes?
Yeah.
Okay. So I'm going to show you the entire Hong Kong, by the way. We are only part of it. Okay. 10 minutes. Sorry about that. Okay. So 10 minutes. So this is the area that has been designated to be poor area. So I told the government that actually they need to do something to it to make it better. And this is at the end of the day what they did, to put an oasis to the site where it is most needed. And next time you go to Hong Kong, try to visit this oasis. This is called Central Market. And this is another site that is in the neighborhood, and they have a problem. So we told them that actually you could do something like that. If you do this, then none of the problem will exist anymore. So basically, the disposition of the block, the layout of the air path, and also the greenery connection and things like that. And the bulk of the building has to be controlled. Things like that. They actually built more than the original site, but then the environment is much better. So next time you go to Hong Kong, also visit this. Okay, this is actually much better because this is the neighborhood that people live in. So a lot of old people are enjoying now what they call the outdoor park. That is also their home. Okay, so 5 minutes. Okay, this is how it looks like now. You may not like it, but the more important thing is the bottom part. So as I told you, actually, if you get the bottom part sorted out properly, it doesn't really matter how tall these buildings are. Okay, so sort out the more important things, and you should be okay. So this is Kwun Tong. I don't want to talk about this. This is Kaohsiung. This is my wife's city. So since she's here, so I try to talk about it. But since I have only 5 minutes, I will leave it to the next generation. Okay, so we did the study for Kaohsiung, and then we tell them how to respect the water system, the wind systems, and the greenery system. And if you do it properly, then the mayor will be re-elected, and the city will look like this. And they implement some of the features. Okay, not all of them, but at least they know what problem they should solve, which is But I told them that this is the problem, but you have a lot of help nearby. Try to connect the help to you, then you solve the problem there. So don't look at the problem and try to solve it. Look at where the help comes from. The help comes from there. So we say, okay, therefore you do this at this place, you do that, you do that. Okay, then you'll be better. Okay, so this is for those of you who like books, this is one book I would recommend to you. Put science to planning. Okay, this is the book that somehow link the scientific understanding to the planning understanding. Another book for human benefit. Okay, so this is another book by my student. For those of you who have projects in Singapore and you want to know how to deal with Singapore government or the planning system, you can visit my other student who is now doing the mapping for Singapore. And the URA, the Urban Renewal Redevelopment authority is actually using this to scrutinize your design if you were to have a project there. So, and if you don't understand how to do it, ask him. And you can quote my name. You give 20% discount. So okay, and this is the book that you may want to read before you go see it. Okay, I have 5 minutes.
Yeah.
Okay. Now, one of the more important things to get right in tropics is the wind environment. This is the book that is causing a lot of problem in China. Because of this book, China has now a new standard that require master planner to consider the problem every 5 years when they redesign or update their master plan. And the first one was Beijing. And therefore, this document is extremely important because of this particular book that introduced the problem. And so every 5 years, if you go to China, if you look at the master plan, they need to tell you how they respect the environment. And so because of that, this is the Macau. We also did the wind studies for them. I don't want to go into. Now, this is the video, but then this video is too long.
Right.
We're a dancer, and then
Yeah.
people dance. You don't mind people dancing. Use anything.
Oh, that's his work now.
Okay. So this is the this is Macau. The Macau government tried to intensify the land supply by building reclaimed land. It's very close to the metro area that I was talking about. So they say, okay, how big a gap should there be before it has a problem to our old area, and what can we do? Things like that. So we did this particular study for them, and therefore position the island at such a distance that it doesn't affect the old city. And now I can tell you the joke about this, but this study was done by a group in Germany, and the German people, they are very proud of their technology. So they say we will use the fastest computer we have on Earth, okay, something like that, to do this for you, and it will take 3 weeks. And then I say, oh, it's too slow, don't worry, we are in the process of buying another computer that can do it in 3 days. I say, it's still too slow, You know what? They actually literally look in the tender that because they need to do this, they have to buy a computer that can do this in 1 day and send it to the federal government. And since Germany is so rich, they buy 2 of them. So next time you have a big, gigantic scientific problem, ask German. Don't ask Hong Kong because we will charge you. They charge us nothing, 0. They say this is good for science, so we must help you. So something like that. So next time you go to Germany, you say it is good for science. You must help me buy 3 computers. Okay, something like that. But they're very nice. Okay, so you have seen everything. Yeah, I can tell you that no computational people in Australia can do this because this use a computer that has too many recall cores. It's 30 million euro. That's the computer, one computer, 2 of them. 30 million. It's cheap, yeah? It's only 30 million. Anyway, because of these studies, then the government in Macau actually positioned the island properly so that we know nothing can affect. This is the standard that we have already put into our system. And surprise, actually, this city, I can't spell the name. This is something. Brisbane, yeah, Brisbane. This city actually asked me to go and say, can you introduce your system so that we can learn from it? I said, well, I'm quite sure you can copy. I don't mind. So they actually learned from it and actually did it better than us because they therefore introduced many other things that make the buildings better for the neighborhood. Not just wind, but also light and energy and things like that. So they are actually doing better than us. But the initial idea somehow came from us in 2014 or something. But this is the system that we now have in Hong Kong that causes a lot of problem because every project now in Hong Kong needs to go through this system. before they can be approved. Okay, so if you want to build in Hong Kong and your building is big enough and you don't know how to do this, it's very easy. You just give me a call, okay? I'm always available. Okay, and this is the government headquarters. This is the first building that makes use of that system to design. So next time you go to this building, you look at it, and it looks like that. It looks like this. This is the building, okay? And this is the building behind, so it's not itself. So they call it the door is always open, the government is transparent, all this funny rubbish. Actually, if they don't do this, the transport exchange at back will suffer a lot. Okay, so and then we actually tested in the wind tunnel and say that you really need a big hole, and it's cost a lot of money. And actually the architects liked it very much because now he has an excuse to do something that nobody else can do. Put a gigantic hole in the building and call it the government is transparent. We are good government. That kind of nonsense. Actually, the door is on one side. It's always closed with a lot of security guards in front. You cannot even approach it without being searched. But this door, whatever. So next time you go to the building, you know why it has a big hole. And we also implement some new guideline. This one you can download from the website. And so there are some recommendations to turn a city that has this kind of problem to encourage a city that will have that kind of characteristics. So now the metro area is being developed with this in mind, so that they will have policy that encourage some of these things to happen. As I told you, if you build a high density city, get this layer completely correct solid, then the building can go anyhow you want. It doesn't really matter because we walk like this. We don't walk like this all the time, okay? And this is how we see things. And if you can make that good enough, then people will forget about whether or not you have a 60-story building or a 70-story building. For them, it's the same. But for the bottom, it means a lot of difference. So I always encourage the developer to say, do this and don't worry about that. And the government will give you 10% more anyway. So you win. And this is the guideline that we say, okay, if you do it like that, then you have to follow some calculation. So they now need to demonstrate that at the bottom, they have done enough to earn that 10% on top by using a certain formula that we developed. And some of these things that I always recommend the government to do, the more important thing is this guy here. The coverage, make sure the site coverage. And then the thing that I showed you just now is building permeability. And this is the building that next time you go to this area, you should visit. It has a number of big holes in it because the wind actually goes through to the neighborhood at the back. So this side of the building is set back, and they put in 3 holes just on top of the canopy layer of the buildings behind, so that the wind actually benefits them. And this building is now very welcomed by people around. These are the building behind it. So this hole actually bringing the air from the sea all the way to the neighborhood and wash out some of the dirt and things like that. And at the bottom, they also have one opening. So at the ground level, they also this is what we call the building permeability. From there, 1, 2, 3, 4, 5, and then this one here, 6 of them. So this building has earned that 10% on top already. This Hudson Fox or something, some American, American company. When they first come, they want to build their buildings in a very kind of a Zaha Hadid way, okay, whatever. So, and then tell us that it's interesting. I say I don't want a building that is interesting. I want a building that benefits the society. And later on, when we discuss, he find out that this is also interesting. But for me, it benefits the society. I don't mind it's interesting. Okay, but so they're happy and I'm happy. Okay, this last slide is the guidebook that we put together on urban climate, and you can download it from the Hong Kong GBC website, and you will be able to have more examples of what we have done and what Hong Kong is doing to improve the environment and take into account urban climatology. Thank you very much. So next question.
It's very, very informative, comprehensive presentation. Thank you. We were going to have a small panel discussion, but unfortunately we've run out of time and we don't want to stand between you and a bit of food and drink. But in the crowd, we do have 4 professors here from the School of Built Environment at UNSW. So Professor Matt Santamuros, Professor Deo Prasad, Professor Phil Oldfield, and Associate Professor Lan Dick. I do encourage you to ask them questions in the networking session afterwards, as their expertise spans across a number of areas. Do we have time for one or two questions from the audience now?
Whoever asks a question get a free copy of this, okay?
My consideration is more from like the transportation aspect. I know that you mentioned that maybe if we ensure the quality is from the ground, then no matter it's 40-story or 60 stories on the top, it doesn't really matter. But from the transport aspect, it will bring additional pressure to the public transportation. So how does Hong Kong balance the pressures of the transportation and
Okay, now I tell you that Hong Kong solved the problem by making sure that cars are too expensive to own. Number one. Okay, so if you drive a car, you're an idiot or you are very rich. Okay, number one. Number two is a public transport system. German professors came to Hong Kong and say, "Can you show me the train schedule of?" I say the train come every 2 minutes. So and that capacity actually can allow you to build anything you want. Yeah, on site. Transportation system, mass transit, and stop the car going into the city or make the car so expensive that. Huh?
The very first several image you showed, you're showing that the height is built along the natural line, but will you have any other measures to limit the car parking?
As I say, the government actually kind of deliberately discourage people driving into the city. So if you drive in the city, you spend a lot of time sitting there, okay, because they cannot move. And the car parking is extremely expensive. And then everything else is expensive. The cars are expensive. The chauffeur is expensive. And if you do the wrong thing, the tickets are expensive. So at the end of the day, 99% of our journey are done by public transport, the metro system. And the metro system is extremely efficient. You go from A to B much faster than to drive a car. Honestly, you only need the car to show off, nothing else. Okay, so therefore there are lots of very expensive cars in Hong Kong, but they're not, nobody driving. We have 7 million people. We have 200,000 cars. That's all the cars we have, and we have 200,000 buses. That's the transportation system. Okay, so now you know what car you drive, by the way, Ferrari or. Good. Okay, so
Other questions? I think we might have to call there. If you do have any more questions,
maybe
feel
one
free
from
at
the
the networking drinks. There's just one more.
One more from
last item on the agenda. And
We do have a small gift,
Oh.
or quite a heavy gift. Professor, to thank you for your time, and for your your fascinating talk this evening.
Thank you.
Really do appreciate it. For those of you who don't know, Professor Edward Ng has been with us for a few days at the School of Built Environment at UNSW, and we've had a workshop yesterday and the public talk today, and so we're indebted to your experience, Professor. And if you could join me in giving Professor Edward.
So thanks everyone. Feel free to move on. Have something to eat. Thank you.